And welcome to ProLearnix. You ever wonder what makes a planet spin around the sun, or what makes a ball fly when you kick it, or even just what keeps your feet on the ground? Well, it all comes down to one single fundamental idea that honestly runs the entire universe. So today, we're going to dive right into the world of force. So let's think about this for a second. What is that thing that makes a ball soar through the air? Or, what keeps all of us from just floating off into space? It's this invisible power, and I promise you, by the time we're done here, you are going to start seeing it absolutely everywhere. And you know what? At its core, the definition is so simple. A force is just a push or a pull on an object. That's it. That's literally it. Every single thing, from a giant galaxy spitting out in space to you just opening a door, it all boils down to that simple push or pull. Okay, so here's the game plan. We're going to start with what a force actually does. Then we'll get into the two main kinds, the ones that touch and the ones that work from a distance. And to wrap it all up, we'll look at what happens when forces team up or, fight each other. Let's get into it. All right, first up, the many effects of force. How do you even know a force is there if you can't see it, right? Well, you see what it does. A force is all about its effects on an object. And believe me, it can do a whole lot. Think about a soccer ball just sitting on the field. It's not going anywhere on its own, right? It's just going to sit there. It needs a force, a good kick, to get it moving. That push is what starts the motion. And of course, it works the other way around too. That ball flying towards the net, it can be stopped. A goalie's hands provide that opposing force, stopping the ball dead in its tracks. A perfect example. But here's the thing, force isn't just a simple on-off switch. Nope. If something is already moving, you can use force to change its speed. Think about pushing someone on a swing. If you push them while they're already moving forward, they're going to go faster and higher, right? That's force changing the speed. A force can also totally change where something is going. You're driving a car straight down the road. A little force on that steering wheel and bam, you're turning. You can change your path completely, all thanks to a simple force. And get this. Force isn't just about motion. It can actually change the physical shape or size of an object. Just grab a sponge and squeeze it. You're applying force, and you can literally see it get smaller and change its shape right there in your hand. So now that we know all the things a force can do, let's talk about the different types. Basically, you can put every force in the universe into one of two big buckets: contact forces, where things have to actually touch, and non-contact forces, the ones that seem to work like magic, from a distance. All right, let's dive into that first bucket, contact forces. These are the ones that make the most sense to us, probably because we feel them every single day. They're all about direct touch. And we're going to look at three main types here. First, the power from our own muscles. Second, the force that fights against motion. And third, a special kind of friction you find in water and air. Okay, muscular force. This is the one you know best. In fact, you're probably using it right now. Anytime you lift something, push something, pull something, you're using muscular force. It's your muscles doing the work, plain and simple. Next up, friction. I like to think of friction as the ultimate force of opposition. Anytime something tries to move, friction is there pushing back in the other direction. It's why a ball eventually stops rolling. It's why you have to keep pedaling your bike. And it's something engineers are obsessed with. They want less of it in an engine, but a whole lot more of it in your brakes. Okay, time to get into the really cool, kind of mysterious stuff. Non-contact forces. These are the ones that can push or pull something without ever touching it. It's where physics starts to feel a little bit like magic. And we're going to hit three big ones: the invisible push and pull of magnets, that crackle you get from static electricity, and, well, the force that holds the entire universe together. No big deal. You've totally felt this before, right? If you've ever played with magnets, you know that feeling. You bring two of them close, and even before they touch, you can feel them either pull together or push apart. That invisible field of energy, that's magnetic force. How about this one? Remember in school when you'd rub a plastic ruler on your hair or a sweater, you build up that static charge, then you hold it over tiny little bits of paper and they jump up and stick to it. That's electrostatic force. It's another one of those amazing forces that works from a distance. And now, the big one, the force of gravity. It's the reason anything you drop falls down instead of up. It's the Earth constantly pulling on you, on me, on everything. It's this constant, invisible force that literally shapes our entire world. Okay, so this is super important to understand. In the real world, it's almost never just one force acting on something. It's more like a constant tug of war from all different directions. So the big question is, what happens when all those different forces combine? Luckily, it's pretty straightforward. It all comes down to two basic ideas. If forces are pulling in the same direction, they just add up and get stronger. But if they're pulling in opposite directions, well, they start to cancel each other out. Let's take an example. Say you and a friend are pushing a heavy box. If you both push in the same direction, your forces combine. So if you're pushing with 3 newtons of force, that's just the unit we use to measure it, and your friend is also pushing with 3 newtons, the total force on that box is 6 newtons. Easy, right? But what happens if you two push on that box from opposite sides with the exact same amount of strength? You're pushing with 3 newtons, your friend is pushing with 3 newtons. The forces are perfectly balanced. They cancel each other out completely. The total force, 0. And that box isn't going anywhere. Okay, so that leads to the final piece of the puzzle. What happens when those opposing forces aren't equal? This is like a real tug of war, where one side is always a little stronger. If one team pulls with, say, 16 newtons and the other team only pulls with 13, the forces are unbalanced. The winner is the stronger side, and the rope moves in their direction with a net force of 3 newtons. It's all about who's stronger. So, just for a second, right now, as you're sitting or standing there, think about it. Gravity is pulling you down. Your chair or the floor is pushing right back up. The air is pressing on you. There are these countless invisible forces in a constant, silent dance all around you. Now that you know about them, what's the first one you'll notice?